continuing on, in terms of intensity, for constructive interference, final intensity is proportional to square of the amplitude of the resultant wave. So that is I is proportional to R square, and R square is equal to, rather R is equal to 2a cos phi by 2 whole square. So intensity is 4a square, where I naught is proportional to a square. So this is I naught cos square phi by 2. So cos square phi by 2 can take the values, its maximum value can be 1. That is possible. Cos phi by 2, you can take the value plus or minus 1. So phi is possible when it is 0. 2 pi, when phi is 2 pi, cos pi by 2 will be 2 pi by 2. So that is pi. This is 4 pi, 6 pi, and this goes on as 2 pi into n. So generally the phase difference between the waves, phase difference phi should be n into 2 pi. So that is, or it should be 0, where n is an integer, where n is 0, 1, 2, 3, and it goes on. So if I consider a small example of one light wave moving like this, this is wave 1. If I consider the second wave moving with the same amplitude, say like this only, the resultant amplitude will be adding up. Both are A and A. So resultant amplitude shoots up to 2A, and this also shoots up to minus 2A in this case, where wave 2 is red. Wave 2 is red. Now they both reach their maxima and 0 value at the same time. That is why these waves are in phase. So this is a case of phase difference being 0. Now what about the phase difference being 2 pi? If I consider one wave like this, so this is where the first cycle ends. The time period for this is t. The path it travels is one wavelength up till here. Up till here, lambda it is. If the second wave starts, at this position, joins at this position with the black wave, then already the angular displacement of the first wave is 2 pi. Already the angular displacement of the first wave is 2 pi, and path difference is lambda. How much more linear path the first wave has travelled? It is one complete wavelength. So path difference lambda corresponds to 2 pi of phase difference. This is path difference delta. Path difference delta corresponds to n lambda if the phase difference is phi. So now if we take the ratio of phi by delta, it will be n into 2 pi divided by n lambda. So finally phase difference phi is equal to 2 pi by lambda into delta. So phase difference is equal to 2 pi by lambda into path difference. Path difference is the formula which has to be taken note of. So here the path difference is lambda, phase difference is 2 pi, and it continues. However, here it is going to give a constructive interference of 2a and 2a here, whereas this is a minus a and plus a here, whereas this is minus 2a. This is how the constructive interference takes place using two light waves which are from coherent sources of same amplitude. However, if they are of different amplitude, for waves of different amplitude, say A1 and A2, then y1 equal to A1 sin omega t, y2 equal to A2 sin omega t plus phi. So the phase difference between the two waves is now phi. So the resultant amplitude will be R is equal to root of, it is nothing but the vector sum according to superposition principle. So vector sum means you have to use parallelogram law of vector addition, where the angular difference is phi. So it is a1 square plus a2 square plus 2a1 a2 cos phi is the amplitude of the resultant wave. Now, when for constructive interference, phi is 0 if we take, then it will be R is equal to root of a1 square plus a2 square plus 2a1 a2 cos 0 is 1, then it is a plus b plus 2a b. So that will be resultant amplitude will be root of a1 plus a2 whole square, implies resultant amplitude will be a1 plus a2 for two waves with different amplitudes. So for resultant amplitude during constructive interferences, where two individual waves have the different amplitudes a1 and a2, the resultant amplitude for constructive interference is a1 plus a2. So this is a maximum intensity or maximum amplitude you can get during the interference of the two waves. So squaring this now, R square is a1 plus a2 square. So the maximum intensity is a1 plus a2 whole square is a condition for maximum intensity of the resultant wave when the two interfering waves are of different amplitudes a1 and a2. Now coming back, had it been a1 is equal to a2, if a1 is equal to a2, then I max would be a1 plus a1, 2a1, it would be 4a1 square. It would be 4a1 square. That is a maximum amplitude if they are of the same amplitude. If they are of different amplitude, this is a case. This can also be written as I maximum is equal to root of I1 plus root of I2 whole square. So that is I maximum is equal to root of I1 square plus root of I2 square plus root of I1 root of I2. This is A plus B whole square formula. So I max can also be written as I1 plus I2 plus 2 root I1 I2. This is another formula which we can think of during constructive interference. Similarly, if A1 is equal to A2, then I1 is equal to I2. Then in that case, I maximum will be I1 plus 2, I1 root I1 I1. So it will be 2I1 plus 2 I1 inside the root, when they multiply they become I1 square, they come out. So it is 4I1 is the intensity, which can be directly seen here also, which is A1 square is 4I1, A1 is I1, so they can be interlinked.